Have you ever wondered how a simple magnet can move things without even touching them? It almost feels like magic, right? You hold a magnet near a pile of paper clips and suddenly they leap toward it as if pulled by an invisible hand. But what's really going on here? Why do some objects get pulled in, while others don't seem to care at all? And what if I told you that this mysterious force isn't just found in your toy box or on your fridge, but is actually a huge part of our planet itself? It's true. Not enough people talk about the fact that Earth itself is basically one gigantic magnet floating through space with its own powerful magnetic field. This invisible force is all around us, shaping the way we navigate, protecting us from cosmic radiation, and even creating some of the most beautiful natural wonders on the planet. Let's break it down a bit. Magnets are special objects that create an invisible force field known as a magnetic field. This field can pull or push certain metals like iron, nickel, and cobalt. That's why when you bring a magnet close to a pile of iron nails, they jump toward it, but plastic or wood doesn't budge. The magnetic field is like an invisible bubble of energy that surrounds the magnet, reaching out to grab onto things that it likes. Every magnet, no matter how big or small, has two special ends called poles. One is the North Pole and the other is the South Pole. These poles are where the magnetic force is strongest. If you've ever played with a bar magnet, you might have noticed that the ends are the only places where it really grabs onto metal objects. Here's something cool. If you bring the North Pole of one magnet close to the South Pole of another, they snap together with a satisfying click. Opposites really do attract. This is because the magnetic field lines flow from the North Pole of one magnet to the South Pole of the other, creating a strong connection. But what happens if you try to push two North Poles together, or two South Poles? They stubbornly refuse to connect, pushing away from each other no matter how hard you try. This is called repulsion, and it's a key part of how magnets work. Like poles repel, while opposite poles attract. Now here's where things get really wild. Earth itself acts just like a gigantic magnet. Imagine the whole planet as a giant bar magnet, with a North Pole and a South Pole, and a massive magnetic field stretching far out into space. This field is so big it even protects us from dangerous particles streaming in from the sun. Deep beneath our feet, the Earth's core is made of molten iron and nickel. As this hot, liquid metal swirls and churns, it generates electric currents. These currents create Earth's magnetic field, which extends thousands of kilometers above the surface. Without this churning, we wouldn't have a magnetic field at all. That's why our planet has a North Pole and a South Pole, just like the bar magnets you play with. These aren't just points on a map. They're the places where Earth's magnetic field is strongest. Explorers and scientists have traveled to these remote spots, braving icy winds and snow, all to study the mysteries of our